Hey all, welcome back. I'm back with one more interesting topic. Today we are going to discuss about behavioral modeling. Okay, so until now we have discussed like gate level modeling and data flow modeling, and now we have come to the behavioral modeling. So I have already explained it in the previous classes, like behavioral modeling is the highest layer of abstraction. Okay, now if you are coming from the lowest level is the switch level, but in verilog we doesn't go for switch level, so that is why the lowest level in case of verilog is gate level, or we will also call it as structural level. Okay, so in this gate level what we need is we just need the structure of our particular um, design. Okay, by seeing the structure we will be writing the code based by using the logic gates like AND gate, OR gate. Okay, by using these gate primitives you will be writing the code. Then after that comes the data flow modeling. In this data flow modeling what you will do, you will write the code based on how the data is flowing between the registers. Based on that you will be writing the code, and then come to behavioral level modeling. So from the name itself we can say that in behavioral level modeling we will leave the structure and also we will leave the data, like how the data is flowing or how is the structure. Okay, so apart from all this we will be writing the program based on the algorithm. Okay, sorry, how your circuit is behaving. Okay, so based on that behavior, based on the algorithm you will be writing the code in behavioral level modeling. Okay, so that is why, because when we are designing like a higher circuits, okay, we are designing high end circuits, because whenever we are studying verilog, basically combinational circuits, sequential circuits, all this, but these are just a part of verilog. Okay, but when you go to the real field you will be working on like protocols, like you need to know about APV protocol, AHV protocol, AXI protocols. Okay, ethernet, UART. Okay, these are different types of protocols you need, you will be working on those. Okay, you don't use these combinational circuits and say yes you will use, but they are just a part. Okay, they are not the entire thing that you will be using in the real time field. Okay, so because of that when you are designing such complex circuits, okay, you just don't think of like writing the code in some gate level or data flow. Okay, there should be some high level of abstraction which is used by you in order to write those type of protocols. So that is this behavioral level modeling. That is why this behavioral modeling is called highest layer of abstraction, because you will be writing your code based on certain algorithm, based on the behavior of your circuit. So in this behavioral modeling you will be using two categories. One is initial block and another is always block. If you see here, this is the initial block and always block. So these are the two procedural blocks you will be studying in case of behavioral modeling in verilog. Okay, these two are really important, because I think you already know about this initial block, because we have already seen how to write a test bench, is it or not? Like by using for combinational circuits in data flow and gate level also, I already explained how to write a test bench code. Okay, in test bench code if you see, everything you will be writing within initial block, is it or not? Initial, begin, end. Yes, so this is the initial block. But in this behavioral modeling we will be studying it in deep, like what is this initial block and why is this used and all, we will be studying this initial block. And there is another block which is called always block. Okay, these two we will be studying in this behavioral modeling. So now assignments. So basically you are having two types of assignments in verilog. Assignment is nothing but you assigning some value. Okay, you are assigning some value to your very output, or you are assigning some logic to your output. Okay, so this is called assignment. Assignment is nothing but you are giving something. Okay, so this assignment in verilog, it is categorized into two parts. One is continuous assignment and the second one is procedural assignment. Okay, I think you already learned about this continuous assignment. This is continuous assignment is nothing but you will be learning in data flow modeling. Okay, in data flow modeling, I already explained you about the continuous assignment. What is the continuous assignment and what are the rules in the continuous assignment? Okay, if you didn't see that, I'll be linking that in the description box. You can go check it out, right? So this is about continuous assignment, and in continuous assignment, what is the thing that you will be using? You will be using the assign keyword. Okay, assign keyword is the must, is a must in continuous assignment. Okay, in this assign keyword, what will be happening? So as the value of LHS is updated whenever RHS changes, that means here in assign keyword, how will be the syntax? Assign LHS equal to RHS. So as soon as there are any changes in the RHS expression, then that expression will be automatically updated in the LHS. Why? Because this LHS will be activated in active region of the verilog. Okay, since LHS is activated in active region, so that is why any update in RHS will be immediately get impacted on the LHS. Okay, so this is what basically the assign keyword is. Now coming to procedural block, procedural assignment. So in this procedural assignment, there are again two assignments, like two kinds. One is initial and another is always. So in initial block, you will be using the initial keyword. Okay, in always block, you will be using always keyword, right? So by using the initial keyword, you will be working on the initial block, and by using always keyword, you will be writing the always block. Okay, and coming to this initial and always, initial is executed only once. That means whatever that you are writing inside this initial, like initial, begin and end, whatever code that you are writing within this initial block, this is executed only once. Okay, it can't be executed again. Okay, once the execution is finished, the simulator will be coming out of that particular thing, but it can't be executed more than once in case of initial block. But always, from the name itself, you could say that means this is executed until the condition is satisfied. That means you will be writing a condition with this always block. Always at the rate, you will be writing some condition. So until this condition is being satisfied, this always block will be continuously executing. Like, it's just like a for loop. Like in for loop, you will be writing the condition, you will be writing some condition, and until that condition is false, it will be continuously executing. Is it or not? That is how in this always block, until this condition is satisfied, this block will be executed. If this condition is not satisfied, then this particular always block, the statements within this particular always block will not be executed. Okay, that is the difference between initial and always. In initial, there won't be any condition. Whatever statements that you are writing within the initial block, they are executed once. Whereas in always block, it will be followed by a condition, and until that condition is satisfied, the always block will be continuously executing. Clear? This is the difference between initial and always. Whereas coming to assign keyword is nothing but you will be writing the assign keyword, and it will be executed immediately in the active region. But the only rule for assign block is that that particular LHS, whatever condition that you are taking, LHS and RHS, that should always be, the LHS one should always be of wire data type, but it should not be rich. Okay, so this is the assignments that you will be seeing in the verilog. One is continuous and one is procedural. Okay, now coming to initial block. Okay, first we'll be discussing about initial block. So this procedural block is executed only once, as I already told you, when the verilog simulation begins, that is at time step 0. That means this initial block will be executed only once, and it will be starting at the time unit of 0. Time unit of 0 is nothing but at the starting of the clock, we can say. Okay, at this starting of the clock only it will be starting. Okay, it is a non-synthesizable block, and it cannot contribute to building design schematic development. This is really important, guys. This block is mainly used in test bench. So basically, what is this non-synthesizable and synthesizable? So anything in your hardware description language. Okay, like any keyword in your hardware description language, if that can be converted into the hardware, real hardware, then that is called synthesizable. Okay, let me give you a small example. For example, if you are writing and, okay, you are writing the end primitive like end some y. Okay, for example, this is your AND gate. Okay, y comma a comma b. Okay, you're writing this logic. So whenever you're writing this logic in your hardware description language, what does this mean? As soon as you are writing this language, this particular logic, then that AND gate will be, it will be converted into real hardware. Like this AND is converted into the AND gate here. Similarly, like OR is converted into OR gate. Similarly, like XOR is converted into XOR gate. Okay, like that, anything which can be converted into hardware is called synthesizable thing. Okay, which can't be converted into hardware. Okay, just like initial is something which is not synthesizable. Not synthesizable means it can't be converted into hardware. So that is why mostly it is used in test bench, because in RTL what we are writing, mostly they should be synthesizable. I can't say that they are 100%, but they should be synthesizable. So that is why in test bench it is just for verification, is it or not? So for verification purpose we don't need everything to be synthesizable. So that is why mostly we will be using it in the initial block in test bench. I think you got my point. What is the difference between synthesizable and not synthesizable? In simple words, anything that can be converted into hardware is a synthesizable thing, and which can't be converted into hardware is a non-synthesizable thing. Okay, and in initial block is the non-synthesizable, and this is also one of the very important interview question, like initial block, is it synthesizable or not synthesizable? Okay, so this is the difference between like synthesizable and non-synthesizable thing. Okay, so as I already told you, in initial block you will be using the initial keyword. Okay, this is already predefined in the verilog library, so you will be writing it with initial keyword is used to declare initial procedural block. Got my point? And here, if the block consists of more than one statement, the statements are enclosed within begin end statements. I think you already noted, that is what I told you. So initial, okay, if you have only one statement to execute, if you are writing, for example, if you are writing only $1 display, then there is no need of begin and end here, and you can directly write end module or else like this something. For example, if you are having like some group of statement, if you are having like 5 displays, if you want to display 5 time displays, okay, that means it is nothing but group of 5 displays. So when you want to execute all these group of statements, then they should be between begin and end. Got my point? This is the meaning of this. If more than one initial block is declared in the module, all the blocks will run concurrently. This is also very important. That means, for example, you are writing here module test page, and you are writing like reg values and wire, and then your dut instantiation. Okay, everything is done, and now you are writing your initial block. Okay, now you are passing some values like a equal to 0, b equal to 1, c equal to 0. In this way you are passing a equal to 1, b equal to 0, c equal to 1. In this way you are passing some 4 or 5 values, and then after begin you will be writing end. Okay, this is my first initial block. If you see, yes, and then I am writing another initial block. Okay, in this initial block I am writing dollar monitor. Okay, in order to monitor all the values like a, b, c, all these values, like out every value I want to write it. Okay, I want to monitor it, and then end module. Okay, if you see my this particular program here, this is my first initial block and this is my second initial block. So in this program I'm having two initial blocks, is it or not? So in this way, if you are having more than one initial block in your test bench, it is not wrong. You can have multiple initial blocks in your test bench TB. Okay, and all these initial blocks will be running concurrently. That means all the initial blocks will be starting, as I already told you in the starting. Initial block means it will be starting at 0 time unit. Is it or not? So this my particular first initial block will be starting at 0 time unit, and then this also will be starting at 0 time unit. That means even if you are writing 5 initial blocks, all the 5 initial blocks will be starting at 0 time unit only. Got my point? This is what that meaning is. That means when you are writing something, they will be running parallelly. That means all will be starting at 0 time unit. Got my point? So and every individual block may finish their execution since they are starting at 0 time unit. So based on the delays that you are giving and all, every block will be independent of one another. That means one block is not dependent on another. Okay, one block's execution doesn't matter for the second block execution. All will be running parallelly. Okay, and one more important thing here is nested initial blocks are not valid. Okay, what is that means? Okay, nested means if you are writing two initial blocks, you should be writing like after initial, if you are beginning end, after ending only you should be starting another initial block. Okay, that means you should not write initial within initial. Initial, begin, okay, have executed some statements, and again if you are writing it initial, again begin, and then executed some statements and ended this initial block here, and then ended this initial block here. This is the wrong case. Got my point? Nested blocks are not allowed in initial block. Okay, if you can, it can execute at 0 time or take some time depending on the delay. That is what I already told you. Got my point? So this is the syntax for initial block, like initial, okay, one statement. Either if it is small single statement, no need of begin and end. If there are multiple statements, it should be with begin and end. So this is how, see, some module, okay, initial, begin, and I'm throwing some values, and display and end module. Okay, just as simple as that. So this is how you will be writing. See, these are three initial blocks. Here if you see, all these three initial blocks will be starting at 0 time unit only. Okay, here see I1 I2. In the first initial block, since only one statement, no begin and end. Okay, I1 equal to 0. In the second initial block, I have displayed I2 value as 5 and displayed since two statements, so begin and end. And then in the third initial block, I have taken 5 time units of time, and again I have changed the values of I1 I2. So now what happens means, this is starting, this both three will be starting at 0 time unit, but when coming to the output, this is at 0 time, this is at 0 time, since you didn't give any delay, but this is executed after 5 time units since you have given the delay of 5 time units. Okay, so do one thing. If you are interested, try to execute this in the EDA playground. So what you do is, in order to see the time value, I think you know what to do. So in order to see at what time it is being done, you just do simple thing here, before I1 or after I2, anywhere you insert time equal to percentage of 0t. Okay, and then you keep all this, and then dollar time comma I1 comma I2. In this way, if you insert time means, you can see the time along with this values also. Okay, so if you are interested, you can do that, and if you have any doubts regarding that, if you face any problem, you can comment me in the ping box, right? So this is how you will be using the keyword, like initial block. See, initial block, this is my block 1, this is my block 2, this is my block 3. Okay, if you see in the block 1, yeah, here I have given mentioned with time. Now if you see, I have taken A as 5, and then after 9 time units I have taken again A as 4 tick D2. Okay, this is my first initial block, and this is my second initial block. Okay, and this is my third initial block. Now every initial block will be starting at time 0 only. Okay, so what happens means, this particular block at 0 0 0. Now what happens here, at 0 first A is 5 will be initiated, and then what happens here, this is 9. but this is 5, so which will be the first delay? So 5 will be the first. Now at 5 a equal to 9 will be displayed, because everything, this block will be running parallelly, this will be running parallelly, this will be running parallelly. So because of that, in which way, at which point the delay is less, that will be displayed first. Okay, and then the delay is 9, again at 9 a equal to 2 will be displayed. Got my point? So this is how the initial block will be working. Now, as I already told you, in order to initiate, like after writing some initial block, if you want to terminate or if you want to stop your particular simulation, then what you can do, you can use $finish system task. Okay, in system task, before we have discussed like four topics like $display, $write, $strobe, and $monitor. Okay, if you didn't see that, just check over that also. This is really important. Okay, because you need to know how to write the system tasks in order to see your display, so that is why they are really important. And one more important thing about the system tasks is, the most frequently asked questions in system tasks is, in which region they are executed. Okay, so you need to know in which region $display is being executed, $write is being executed, $strobe and $monitor being executed. So that is very important. Okay, first you go and check over that before coming to this particular thing. Okay, so this is about $display and all. So now along with these four, you are having some more system tasks. One among them is $finish. Okay, from the name itself you could say, in order to terminate your execution, in order to stop your execution, you will be using this $finish. So that means whenever you're giving $finish, that means at particular with particular time delay, if you're giving $finish means it will be stopped, your execution will be stopped at that particular time itself. Okay, here if you see, okay, here at #5, this is my initial, begin, end. Okay, just check this carefully. Initial, begin, #5. Okay, I'm taking two values like I1, I2, and again display, and then within initial only, without okay, I didn't write any other initial block. Within the same initial block, at 5 time units of time, 5 time delay, I'm taking I1, I2, and then again 5 time units of time delay, I'm changing the values of I1, I2 as 0 and 2, and then I'm displaying an end. And then again in another initial block, I am giving that #6 finish. Now what happens, if you see, this will be executed at 5 time units of delay. Okay, this will be starting, that means the execution started 5 time units of delay. Now at 5 time units of delay, what is the I1 value? I1 value is 1, I2 value is 8. That means these two are assigned into I1 and I2, and then displayed. Fine. And then again it should wait for another 5 minutes. That means 5 time cycles, that means 5 plus 5, that means until 10 time cycles it's need to wait. Is it or not? But I have given that at 6 only to stop the execution. Now what happens? So since the execution should stop at 6, so that is why this particular values will not be executed. That means they won't be assigned. Why? Because I have stopped at 6, so I don't need to wait for 10 don't need to wait for, the simulator doesn't need to wait for 10 clock cycles. So that is why only these two values are projected. Got my point? And this is saying that $finish at simulation 6. Got my point? So this is how the $finish is used. Okay, so this is about initial block, and then we will be discussing about always block in the next session. So that is all for today. If you like my explanation, please like and comment in the comment box. Also, do share this video with your friends who are also VLSI aspirants. Okay, so my main motto in starting this channel is to share my views and knowledge on VLSI front end. Okay.